Okay, on to question 3. So you'll see here I've switched PDF manuals now to the LPC 1768 user manual. So this is reference C in the course website. But you should have this up probably likely to this page, which is page 122, 9.5 register description. This is the register description and addresses for the GPIO general purpose input and output ports and pins on this LPC 1768 board. So the first question, number 3 here, is write a sequence of assembly instructions that sets pins 1, 5, 8, 12, 15, 30, and 31 as inputs, and the rest of the pins as outputs on GPIO port 3. So essentially here we're being asked to leave some of them as inputs, make the rest outputs. So for GPIO direction, we know that 0 equals input and 1 equals output. So we're being asked to change the directions of the pins, and this is just from the notes to know that FIO dir is the direction control register. So this tells us whether for each GPIO port or pin, the IO part stands for input or output. This is what determines whether it's an input or output at the time. So here we're just being asked to set some of them to inputs, set some of them to outputs. We're being asked to do this on GPIO port 3. So this means that we would have FIO 3 dir is what's going to change the pins for port 3. And so the address of that we can find in the guide over here. FIO 3 dir equals OX 2009 CO60. And I'm being asked to set some of these pins to specifically inputs or outputs, meaning I want to construct a bitmap that has those values specified here, input or output, for the specified pins. So I'm basically going to have another bitmap that's going to be 32 bits long, labeled bit 31 over to bit 0, and I'm going to specify whether they're inputs or outputs. So starting off, 31 and 30 are both going to be inputs, which means they're going to be zeros. Everything then down to bit 15, reading from this list, is going to be an output. So the rest of them are going to be ones. So that's the next 12 bits that are all going to be, or 14 bits here that are all going to be ones. Then we have bit 15 is an input, 14, 13, 12 is also an input, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So we're just counting the bits, and we could label them, 31, 30, on down to 0, 1, 2, 3. And the bit position in this bitmap corresponds to which pin it is describing, whether it's an input or output. And so then we have to translate this to hex so that we can put it into our assembly code. And so that's just using our handy-dandy hex table. 011 is 3. We're going to have 3 Fs in a row. 0110 is 6. 1110 is E. 1101 is D. And then 1101 is also D. So that's our hex that's going to go into the bitmap that we're going to store into here. So it's asking us to write a sequence of assembly instructions. This means we're going to do a couple move W, move T pairs, and then we're going to do a store that takes the bitmap and stores it into the address for FIO3 dir. So that store is what actually puts this into memory, makes it happen on the board so that these would be specified as inputs or outputs. So let's go ahead and do that. So we're going to start with a move W R0 OX, and remember the move W is getting the bottom part, so I'm going to get the CO60, move W R0, the top part of it, OX 2009. And I'm going to make a comment that R0 equals FIO 3 dir, just so I can remember that that's what I put there. Comments are with a semicolon there. Sorry, this should have been move T here instead of a move W because we're putting in the top part of the register. And then we have a move W R1, And this is where we're going to put our bitmap in. So let's get the bottom part first. That's 6E D D, and then a move T R1 OX 3 F F F, and then R1 is our bitmap for FIO 3 dir. So that's the bitmap that we're going to store over top of whatever was there. Now I need to do my store, and I'm going to take the bitmap in R1, and I'm going to store that into the address in the brackets R0. So keep in mind, the thing in the brackets should be the address. That should be like what you're taking from the manual here every time, and then the value that you're storing there will be the bitmap of whatever value you're specifying that you want to go into that place in memory. So this will overwrite memory such that those pins are inputs, the ones that are zeros, and the rest of the pins are outputs, so the rest of the pins are ones.